Rene Descartes gave us his law of signs, and we can tell the possible number of positive and negative zeros or roots. And the way we do that is we look for the change in sign. So there's one, and here's another change in sign, and here's another change in sign. So that looks like 3 positives, okay? And then because some of our roots could be irrational or imaginary, they go down by 2's because, as you remember from the last problem, every irrational or imaginary root has its conjugate buddy. So it goes down by, it's either 3 or it could be 1 positive root. Okay? And then let's see what happens when we put in g of -1. This does not mean g times -1. It means I'm putting in -1 for x. When I take it to the 6th power, that's even, so that's a positive. When I put it to the 5th power, it's a negative. When I put it to the 4th, it doesn't change the fact that that's negative. When I put it to the 3rd, it does change that to a negative. When I put x squared with a negative, it doesn't change anything, so it's still positive. When I put -1 with a 9, I get a negative, and I have a negative, which I cannot change because it's a constant. So we had 1 change, 2 changes, and 3 changes. So the same thing goes for our negatives. Could be 3, could be 1. Okay? And since I have 6 possibilities, let's make a little chart here. Okay, so the possible positive, possible negative, and possible imaginary. So could be 3 positive. And if it's 3 positive, then it could be 3 negative and no imaginary. Okay. Or let's see, what else could it be? It could be 1 of these guys and 3 of these guys. Was there any other possibility? Oh, yeah, there was. Hold on. Let me go back to 3. There was another possibility. 3 and no negative. Is it possible there'd be 3? No, that's not a possibility. I was going to say 3, but remember the imaginary roots always come in 2's, so I should have just kept quiet. 1, and then there could be 3, which would then let these guys have a pair, which they like pairs. And let's see, what else could happen? I could have 1 and 1. And then these guys would have 2 pairs. Okay? Is it possible? It's possible that they could all be imaginary, right? I mean, at least according to our chart here. Anyway, I don't like the sound of that. But at least on our chart, that's possible, because at least they'd have 6 pairs, or 3 pairs. That's 3 pairs. So, any other possibilities? Surely seems like there would be. Oh, I said there could be 3 and 1. Why didn't I write that down? 3 and 1, and then there'd be 2. Yeah. What's so bad about that? I started to do that, and then I didn't like it for some reason. Anyway, if I could have 1, 3, then I know I could have 3, 1. And they're both possibilities. Okay, as long as I have an even number left over for the imaginary. This is the only situation where it could avoid all imaginary. Okay? And here, they're both doing the best they can, but then there's still 2 pairs left over. Okay, I think this is all the possibilities. And then, again, if you don't like to see this thing swing around, let me put the graph in here and see what we actually have. And I have to remember which one it was. I think that's it. And so here is the graph. It's too big. Maybe. Come on. Still too big. And you can see the situation here. Let me move it over here. You can see the situation is that there's one negative here, and there's 1 positive here, and so there must be 4 imaginary, right? according to our graph. As I graphed it, that's what I got.